Okay, so now suppose that you have some function like f of x is equal to x sine x. If you want to take the derivative of this function, of course you can use u times v whole prime is equal to u prime times v plus uv prime, and take the derivative of the function, and that would be, for example, that would be based on that f prime of x would be equal to 1 times, for example, sine x plus x times cos x, for example, x times cos x plus sine x. But if you want to take the derivative of this function based on the first principle, then you know that f prime of x is equal to the limit of f of x plus h minus f of x over h as h tends to 0. And over here, basically, f of x plus h is equal to x plus h times sine of x plus h. Sine of x plus h. So then f prime of x is going to be equal to the limit of basically x plus h times sine of x plus h minus f of x, which is x times sine x over h as h tends to 0, and that is equal to I suppose here you need to just multiply Okay, so here what you can do is that you can write as the limit of basically x plus h times sine of x sine x plus sine x plus y is equal to sine x cos y plus cos x sine y. So that is equal to sine x cos h plus cos x sine h minus x times sine x over h as h tends to 0, and that is equal to basically the limit of x times sine x times cos h times cos h plus x times cos x times sine h plus h times sine x cos h plus h times cos x sine h minus x times sine x over h as h tends to 0. And then you can take x sine x out. So you have over here you have x times sine x in these two terms, x times sine x here. So if I write this as the limit of x times sine x times cos h minus 1, and then you need to take the h out from these two terms. From these two terms you need to take the h out. So basically we took care of this one, and we took care of this one. And from these two terms, if I take an h out, I can write this as sine x cos h plus cos x sine h So this is taken care of, and this is also taken care of, and over here I have x times cos x sine h plus x times cos x sine h over h as h tends to 0. Then I can write this as so you can see that I can write this as the limit of x sine x times cos x cos h minus 1. You can write this as the limit of x times sine x times cos h minus 1 over h as h tends to 0 plus the limit of plus the limit of, and if I write the limit of these two h and h will cancel out, so I can just simply write the limit of sine x cos h plus cos x sine h as h tends to 0, and then over here I can write the limit of x times cos x times cos x times sine h by h as h tends to 0. And so okay, so we said that basically the limit of, there was something that I wrote up here, the limit of 1 minus cos x over x as x tends to 0 is equal to 0, 1 minus cos x. So I can write this as the limit of, if I multiply a negative 1 by this term, I can write it as the limit of, multiply a negative 1 by the numerator, I'll get x times sine x by times 1 minus cos h, instead of cos h minus 1, 1 minus cos h, multiply a negative 1 here, and divided by h as h tends to 0, and then I multiply a negative 1 over here to cancel out what the negative sign that I multiplied here earlier. And then we said that the limit of 1 minus cos x by x, we said that the limit of 1 minus cos x by x as x tends to 0 is equal to 0. So then I can, for example, now ignoring the rest of this, I can write this as negative limit of, for example, x times or 1 minus, basically x times sine x times, for example, 1 minus cos h over h, okay, and then as h tends to 0, and that is equal to the negative of the limit of x times sine x times as h tends to 0 as times the limit of basically 1 minus cos h over h as h tends to 0. And you see that this part is based on this part goes to 0, so the whole thing goes to 0. So this whole part, this basically becomes 0. This whole part becomes 0, and then over here you have, well, when h tends to 0, this becomes cos of 0 is equal to, cos of 0 becomes 1, so you get basically sine x and sine 0 is equal to 0, so this whole thing becomes 0, plus, now if I thinking about this part, I can write it as limit of x as h tends to 0 times the limit of basically cos x as h tends to 0 times the limit of sine h by h as h tends to 0. So limit of x when x tends to 0 is equal to x. Limit of cos x as h tends to 0 is equal to cos x. And the limit of sine h by h, we said that the limit of sine x by x when x tends to 0 is equal to 1. So this part becomes 1. So then you have so this becomes x times cos x. So this is x times cos x. So the derivative becomes, so this is 0, so the whole thing becomes sine x plus x times cos x. That is f prime of x. That is x prime of x. And the function that we had to begin with was x times sine x. The function was f of x is equal to x times sine x. So if I take the derivative of this function based on the product rule, u times v whole prime is equal to u prime v plus u v prime. So then f prime of x is equal to the derivative of this times the second function, the derivative of x is equal to 1, plus this first function times the derivative of the second function, which is sine x plus x times cos x. So that is basically the same thing. So that is that. I have a couple of examples here. We are almost at the end of these examples. Now let's do this one as well. Let's do this one as well. So this one is, I don't know if I have number 2. Okay, so suppose that you want to compute the derivative of f of x is equal to sine 2x. Suppose that you want to calculate the derivative of sine 2x. Now, I just mentioned here that the derivative that sine 2x is equal to 2 sine x cos x. You know that sine 2x is equal to 2 times sine x cos x. So that means that you can write your function as f of x is equal to sine 2 times sine x cos x. of course, when you rewrite your function in terms of some other trigonometric function, you need to make sure that basically 2 times sine x cos x. You do need to make sure that, for example, suppose that I'm using a 2x over here, I'm using x over here, I'm using sine of 2x, I'm using sine x and cos x over here. So you need to make sure that if there is any restrictions on the domain or the range of this function, for example, that the same restrictions are imposed upon the domain and range of the new function, because you're using another trigonometric function to describe the same function over the same function that you had to begin with. So you need to be careful about that. Okay, so meaning that, for example, suppose that you have some function, some trigonometric function over here, f of x is equal to some function in terms of, for example, I don't know, sine, for example. Now, sine of, for example, sine of pi by 2 is defined, is equal to, for example, 1. Sine of pi by 2 is equal to 1. But if you somehow express this function in terms of, for example, somehow you use some sort of identity or something to rewrite this function in terms of not f prime, of course, f of x. Suppose you use some sort of identity to express this function in terms of, for example, tan of x and some other function and some other things over here. Now, for the tan function, pi by 2 is not defined. So then you would get into problem when x is equal to pi by 2. So you need to be careful about that. So these are the little things that you need to be aware of when you, for example, of course, when it comes to solving these problems, you just simply write this as that and this as that, and then you substitute, and then you use different functions to describe, for example, some function, some trigonometric function. But when it comes to the practical application of these basically these equations and these functions, you need to make sure that basically the functions that you use in order to rewrite your original function, that those functions have the same type of basically domain and range as the original function, meaning that you're not losing any information or you're not introducing unnecessarily new information to the function, that sort of thing. So then, considering all that, you have f of x is equal to 2 sine x cos x. Okay. Now, f prime or d by dx of f of x is equal to d by dx of basically 2 sine x cos x. 2 sine x cos x. And now this is a little bit problematic. And it seems that you can, I didn't know this actually, but you can write this as 2 times d by dx of sine x cos x. And the reason why you can do this is that we need to basically take a look at this based on some example and use the first principle to see what happens in the limit. Okay, so I wanted to set up an example, but it's really not necessary to basically to do that, because you know that, for example, let's say you have 2 times sine x times cos x. Let's say that this is f of x. If I take this as just one function, and if I take this as one function, take this as u and take this as v, then of course based on the u times v whole prime is equal to u prime times v plus u v prime, you know that first you need to take the derivative of this function, which is equal to 0. So this becomes 0, so this whole thing becomes 0. So you have only basically the first function, which is just simply the constant times the derivative of the second function. So I can write this as 2 times the derivative of the second function, which is sine x cos x. So that's basically why you can do this. Okay, otherwise you shouldn't just take something out based on the ordinary algebra that you might know. The ordinary algebra doesn't really work that way here. You need to be aware of, meaning that, for example, when you have a 2 over here, it's actually regarded as a function and not just something like, for example, I take it factorizing things and things like that. That's okay, but you need to be careful about the meaning of what you're doing, really. So I can write this as 2 times basically the derivative of this function, which is, again, you can use the same, basically u times v whole prime is equal to u prime times v plus u v prime. And so you can write this as 2 times, for example, u prime is cos x times the second function, which is cos x, plus the first function, which is sine x, times the derivative of the second function. D by dx of cos x is equal to negative sine x, is negative sine x. So this is equal to basically 2 times cos squared x minus sine squared x. And of course you know that cos squared x minus sine squared x is equal to cos 2x. So 2 times cos 2x is the answer. So that if you have a function f of x is equal to sine 2x, then f prime of x is equal to 2 times cos 2x. Cos squared x minus sine squared x. Cos squared x minus sine squared x is cos 2x. Or you can just simply write it as 2 times, for example, cos squared x minus sine squared x, which is basically the same thing. Now, suppose that you have another function, for example, the derivative of cot x. The derivative of cot x, suppose that your f of x is equal to cot x. Of course, we did calculate the derivative of cot x here. And we said that the derivative of cot x is negative cosecant squared x. But let's see how they have done this over here. So, you know that f of x by definition is basically cos x over sin x. So that if you use the quotient rule here, u divided by v whole prime is equal to basically u, what was that? U prime times v is equal to u prime times v minus u v prime over v squared. Use this over here, you would get f prime of x is equal to basically u prime, which is the d by dx of, and you know that d by dx of cos x is equal to negative sine x. So you have negative sine x times the second function here, which is sine x, minus the first function, which is cos x, times the derivative of the second function, which is cos x, over this function whole squared over sine squared x. So you have negative sine squared x minus cos squared x over sine squared x, and you can write this as negative sine squared x plus cos squared x over sine squared x. Now you know that sine squared x plus cos squared x is equal to 1, so that's negative 1 over sine squared x, which is equal to cosecant squared x. That's basically what we got over here, meaning that d by dx of cot x is equal to, there's a negative of course over here, negative cosecant squared x. That is basically that. Okay. And also you can do the same thing using the definition of cot x in terms of tan x. You know that if you have f of x is equal to cot x, then you can write f of x as 1 over tan x. And of course you know that tan x is also equal to 1 over cot x, which is not relevant here, but basically they are, tan and cot are reciprocals of one another. Like for example sine and cosecant. For example, cosecant x is equal to 1 divided by sine x, and also sine x is equal to 1 divided by cosecant x. Also we have secant x is equal to 1 by cos x, for example, and also cos x is equal to 1 by secant x. But anyway, these are again not relevant here, just for the sake of information, for the sake of our information. But if I write f of x is equal to 1 by tan x and u by v whole prime is equal to, let's say, u prime times v minus u v prime over v squared, again I can write f prime of x is equal to basically the derivative of 1 is equal to 0, so that's, this part becomes 0. So you have negative u, so negative 1 times v prime, and we said that d by dx of tan x is equal to basically secant squared x, right? Secant squared x over v squared, which is basically tan squared x. Tan squared x. So that's negative secant squared x by tan squared x. Now you can write this as negative 1 times secant squared x is 1 by cos squared x, and tan squared x is sine squared x by cos squared x. Cos squared x. So if I write this as negative of 1 by cos squared x times the reciprocal of this, which is cos squared x by sine squared x, these two will cancel out, and then you have negative 1 over sine squared x, which is equal to negative cosecant squared x. So again, the same thing, d by dx of cot x is equal to negative cosecant squared x. And when I used to go to college a few years ago, around 2007, we used to memorize all of these things, and of course I didn't understand anything about this whole thing. I had no basically understanding of, for example, when you say that, for example, this is the derivative of this function, I just knew that, for example, if you write d by dx of, for example, 3x cubed, for example, 3x raised to the power 4, for example, I knew that I had to just do some operation like a robot, like a machine, and then multiply this over here 12 times x raised to the power 3, for example. And this was the derivative of this function. I didn't know what this represented. I didn't know what this represented, meaning that I didn't understand the meaning of this part. I didn't understand the meaning of this part. And well, all of these formulas like this just we used to memorize. And basically this was what you were required to write in an examination in order to just get some marks. For the same, for which reason, well, a large part of our education system is just meaningless, because they treat you as a machine, and well, it really doesn't matter in what sort of education system you're in. The problem is that you're not given the time to go through these concepts and learn them and understand them. There is really no time in a course. For example, it's like only 3 months or 4 months, and then the whole thing is over, and then in those 3 months they give you a whole bunch of material, and there is really no time to understand anything. And well, now I suppose the only way to get over that problem really is to just the only solution that I saw back at the time is just to get out of the system and just do it on my own, at my own pace. Otherwise I would have lost my time, I would have lost my money, and I would have got absolutely nothing really. So that's the problem with our education system. It's a great thing, unless except that it treats you absolutely like a machine, and most often than not, you just end up understanding nothing. You just end up memorizing a bunch of things, and then after a few years, probably you will just simply forget the whole thing. So anyway, now the next question that we have here is the last question here. So there is only 2 derivatives left. And suppose that you want to find the derivative of, for example, x raised to the power 5 minus cos x over sine x. Okay, so let's say that this is, for example, h of x, for example. They have called it h of x, we'll call it h of x. So if we can use the quotient rule on this function, meaning that u divided by v whole prime is equal to u prime times v minus u v prime over v squared. Let's see what happens. So h prime of x is equal to basically the derivative of the first function, which is the derivative of this function over here, d by dx of x raised to the power 5 minus cos x times the second function, which is sin x, minus the first function, which is x raised to the power 5 minus cos x times the derivative of the second function times d by dx of sin x divided by sine squared x. Now the derivative of d by dx of x raised to the power 5 minus cos x is equal to basically the derivative of x raised to the power 5 minus d by dx of cos x, which is equal to 5x raised to the power 4 minus negative sin x, which is equal to 5x raised to the power 4 plus sin x. That is the derivative of the first function. And the derivative of sin x is easy. That's cos x. You already know that. So you can write h prime of x as basically the derivative of the first function, which is 5x raised to the power 4 plus sin x times sin x minus x raised to the power 5 minus cos x times the derivative of sin x is cos x, and you divide that by sin squared x. So then, I don't know if you can actually simplify this in any way. Sin x. Okay, so let's multiply. Let's see what we get. So we get basically 5x raised to the power 4 times sin x plus sin squared x minus x raised to the power 5 times cos x minus cos squared x over sin squared x. Now sin squared x over now you see sin squared x minus cos squared x is equal to cos 2x 5 sin squared x minus cos squared x is equal to 1 plus sin x times sin x minus times cos x. There must be something wrong here. 5x raised to the power 4 times sin x sin squared x. Oh, okay, I've made a mistake over here. You see over here the negative is supposed to be of course multiplied by both of these signs. So basically x raised to the power 5 times cos x minus this. So this is equal to 5x raised to the power 4 times sin x plus sin squared x plus, that's a negative sign here, minus x raised to the power 5 times cos x plus cos squared x over sin squared x. Now cos squared x plus sin squared x is equal to 1. So you can write 5x raised to the power 4 times sin x minus x raised to the power 5 times cos x. And these two added together will give you a 1 over sine squared x. That is the answer there. And we have one more of these over here. Let's do that as well. The question is x plus cos x over tan x. Suppose that you have f of x is equal to x plus cos x over tan x. And again, you can use u divided by v whole prime is equal to u prime times v minus u v prime over v squared. Okay, so now f prime of x would be equal to basically u prime, which is the derivative of d by dx of x plus cos x times the second function times tan x minus the first function x plus cos x times the derivative of the second function, which is d by dx of tan x is equal to, let's write the d by dx of tan x over tan squared x. Now d by dx of x plus cos x is equal to d by dx of x plus d by dx of cos x, which is equal to 1 minus sine x. So you can write f prime of x as d by dx of x plus cos x is equal to 1 minus sine x times tan x minus x plus cos x. D by dx of tan x is equal to secant squared x. Secant squared x over tan squared x over tan squared x. Now this is equal to basically tan x minus tan x sin x minus x secant squared x plus secant squared x cos x divided by tan squared x. Now, over here you can write this as tan x times sin x. Tan x times sin x is equal to sin x by cos x times sin x well, I'm going to just write it as it is. There is no point in simplifying it, so I write it as negative tan x sin x, and over here you have negative x times secant squared x, negative secant squared x times cos x over tan squared x. And so you can write this as tan x times 1 minus sin x minus secant squared x times x plus cos x over tan squared x. That is basically the derivative of your function. So in the next video we will talk about the miscellaneous exercise on chapter 13. There is like around 30 derivatives that we will calculate in the next video. So I'll see you in the next video. Thank you.